Okay, so I just stripped the ends of the wires. I've got a few jumper leads here just to clip the sense leads together once we've tried a couple of things. So the first thing, battery's installed, none of the wires are connected together. They're just all sitting here open. So it should be giving me an error due to the fact that it cannot determine what the wiring is. So everything is separated. So if I push the button right now, you can see it says, oh, I don't know what's going on, and it's giving us a warning, flashing light. No greens, no reds, just the warning. So let's clip these together. What that should do is allow us to have the sense wiring think that at least from a sensing perspective, everything's okay. Now, I don't know if it needs to have these also connected to, via a low impedance to each other, sort of simulating a circuit, but we'll find out. So that's the ground, and here's the brown. Not making these touch each other, just shorting their own sense. So this would simulate being hooked up to the wiring panel with two separate connections. If each of these clips I'm putting on is effectively the wiring. So now, at a minimum, it should think that it's connected to the wiring properly. But it may also tell us that it's safe. And we've got green. Yay! So it knows that all the wiring is connected properly. When it's flashing to start with, it's telling us that it's running the test. And if it finds everything is okay, we've now got a green indicator. So next thing to do is to get a power supply, and let's start cranking the voltage up a little bit and see where we can make it kick off. Okay, so what we have right now is 1 volt applied across the green wires and the orange wire. The yellow and the brown are still just connected to each other, but not, they're jumpered but not connected to each other and not connected to a supply. So we've still got just the 1 volt here, and if we do our test, theoretically the threshold is 3 volts, so we should be good. And there we have it, a green light. So I'm going to up it to 2 volts. Okay, now we have 2 volts. So let's just do a test. This is DC we're testing right now, not AC. And we're still good. Let's go to 3 volts. Now, theoretically, if that's the threshold, well, I mean, I'm, 2.998, so it may or may not trip at this level. But let's give it a go. Any red light indicates an issue. So it's not giving us a green, but it's not giving us a red either. It's saying that there's potentially voltage there. Let's go up to 4 volts and see if it's going to give us a red light. Nope. So it's still saying that there is potentially a voltage there, but it's not indicating a high voltage. So the highest I can go on this is 60 volts applied to this, and it's DC still. So L1, L2, L3 are still not illuminating. Now this is between ground and one of the phase wires. Let's just reconfigure that to put it between 2 phase wires and see if that makes any difference. Okay, now I've got 60 volts applied between the orange and yellow wires. So let's just push the light and see what we get. So it's still indicating we've got a problem. If I take it back down to 1 volt, okay, so I've got both channels on my power supply to 1 volt, so that's 2 volts in total. We should get green this time. So it's not only measuring from ground to a phase, but also across phases. So I would imagine it doesn't care where that voltage is. It's detecting a voltage between the wires of more than 3 volts. So we're back to green again. So I don't know what it's going to take to make this thing show red. Let's just check the manual now and see. Okay, according to the manual, L1, L2, L3 indicates the presence of an unsafe AC voltage, not a DC voltage. So we've put in about 60 volts DC and we've had no issues. Now what I've got here is a little quick connect block somewhere. So I'm just going to hook it up and give it 110 volts between the ground and one of the phases, and then we'll do it across the phases and see what lights we get this time. So some of you might be thinking, what is this quick connect? This is quite a common thing in the UK, and what it allows you to do is actually make some quick connections to live, negative and earth with some stripped wires, and then just slam the lid down and it will apply your voltage. But the nice thing is that both the live and the neutral are separately switched with these tines, and it's got a 5 amp fuse in it as well with a neon indicator. As you can see, this is originally sold in the UK for 230 volt operation, 240 volt operation, but it happily will work even on 110, as you can see here. So let me just put this down, and we're going to hook in the ground and one of the phases. So I'm actually going to put the ground to the ground. Okay, so what I have here is I've only connected the ground wire and the orange pair to the live to see what happens. And so when I connect this, you'll see that immediately the red indicator on L2 illuminates. So leg 2, and if we look in here, we'll find in the wiring that L2 is probably, should confirm to be the orange wires. Yep, it is. So I've actually connected it up just as a kind of this kind of diagram here, but I've used the orange on the live instead of the brown on the live, which is live 1. It looks like the unit actually doesn't care. What it's looking for is live voltages on each of the lines, but knowing which one's connected to what would be important too, because I know in North American wiring the neutral is normally connected to ground. So if you're getting an indication on L2, that would indicate that your neutral is not connected properly. In the panel is where it gets grounded, not at the socket or anything like that. So it's very important to be able to know what this is indicating as far as a fault condition may be. So if I then remove this and hook up the brown wires instead, then we should get L1 being indicated as the faulty pair. Right now with it open, if I press this, I should get an error because these two are still not connected back together again. So it's flashing and it's giving me a warning saying that volts may be present. If I just clip these back together again, grab another pair, and we press it again, we should get green because we're now disconnected. And we do, which is great. If I connect this, it immediately, even though it was indicating, you saw it immediately went to L1 and the warning light came on. So if I now run this again, it's going to tell us that there's volts present, and of course the light is indicating that it's an AC volts on L1. I wouldn't be surprised if there's some kind of little transformers in here to provide the isolation, because this is isolated according to everything I've read, to then drive these little LEDs on here. Alright, next test. What I wanted to check, I've got the multimeter here, is I've got 110 volts AC connected to this unit. This is pretty well protected, but do I have any volts on these leads detectable. So that's DC. No, not really. There's what? 2.6 millivolts. Let's go to AC. And we got absolutely nothing on there. If I disconnect this so that it's floating, well, that goes up to about 0.5 volt AC. Probably because it's applying some kind of test signal. Because I told you, when it's actually running tests, it also tries to verify that the thing is wired up properly. So it's going to give me an indication here that there's a problem. And even if I disconnect this, it's still going to give me an indication because I've now broken this connection. Right? It's flashing yellow and it stayed yellow, and then it gave me a steady indication to say that volts are present. That's either DC volts, or with the red lights on, there's an AC voltage component as well. So if I now connect this back to here and run the test, it should say we're good again. And we're good. So when it's running the test, what it's actually doing is it's checking that the 2 oranges or the 2 yellows or the 2 browns or the 2 ground wires are connected together. That's why it's important that you wire this thing up properly, as I showed you in the diagram, where the 2 yellows, for instance, go to their phase as 2 separate connection points to that, because then not only are you verifying that the 2 sense wires have continuity between each other, but that they're also connected to the sensing cable. If you put them on the same terminal, that could fall out and they could still be connected, and everybody would think it's good, and it's not. Whereas if you connect them separately, one of them could still indicate that you've got a mains issue. And we can actually probably demonstrate that, because right now when I connect this, we get the red light for that one phase. Let me just take one of these wires out. We're also going to do a little test here as well to see if there's actually any volts on this wire. So as you can see there, L1, I've got this wire out, is still indicating an issue. But if I run the test, actually it's going to tell me there's a problem anyway, because it's got mains on it. Right, so it's telling me it's still got an issue. If I switch this around, just so that we know it's both sides. Right, now it's not indicating. Ooh, even though there is live on there. But if I run this, it shouldn't give us green, because there's a wire off, there's a fault here. So obviously one of the wires is the voltage detection, and one of the wires is the sensing detection. So if I put that in there, see, we've got our indication. Now we've lost it. Now the question is, do we have mains on here? So let's get our multimeter. Right now there isn't, of course. Let's stick one end on our wire here, and the other end on our brown wire. So we've got no voltages being displayed at the moment. So let's plug this in. Ah, okay, that's interesting. So it's telling us that we actually have 120 volts between that brown wire and this brown wire, AC. Now let's measure that on low impedance, just in case it's some pickup. So we'll measure on AC low impedance and see if it's still there. No. So it's just pickup, probably through a transformer or something like that. When I put the meter to low impedance mode, if that was a real connection, we would be getting some 100 and odd volts again still. Right now it's right down to 1.6 volts. So this is not a direct connection. You're not going to be electrocuting yourself with this thing to ground. Actually, let's just check that to ground. Let's find a good ground point somewhere. So obviously to ground, we're going to get low impedance mode. This is checking my other bench. I did a video a while back on making a bench safety piece of equipment, and it just tripped because the low impedance of this, I'm not sure what the resistance of it is in low impedance mode, but I just put mains across it and it just killed the trip. I don't know if you heard that go in the background, but it just tripped my earth leakage circuit breaker. So that's nice to know. Let's put this back to AC volts before I restore that, and we'll pop it back on. Okay, so let's put this back on. Of course, we're going to get 120 volts. Now let's check between there and here. And so between ground and this sense wire, we've only got 1.4 volts AC. And in low impedance, it doesn't trip my trip either again. So it's still about 2.3 volts. That's probably just the sense voltage that it's using to make sure the wiring is set up properly. We don't have any indicator here, of course, because I've got the wrong wire in there. That's not good. I think we just found a fault with this thing. I have mains voltage, I've got ground connected, and it's not indicating red, which means the sense wire, this one, is, sorry, the mains detect wire has fallen out. But the two wires are not well, they're connected, it's connected to ground, it's not connected to the brown. And it's telling me everything is hunky-dory. It's not. Let's go back to VAC, see if it still gives us the same indication. So if one of these sense wires falls off and it touches the case, it's going to cause you an issue. Let's just try something here. I'm going to ground this sense wire to one of the other pairs. It should still indicate an issue. Nope. So it's gone to the, it's not connecting directly to its pair, but it's indicating that things are okay. Whereas in reality, I have mains present. So we have a potential scenario where if a wire came out, even if it was floating, but it had a relatively low impedance load, because obviously if it's just floating, well, this time it's not indicating it. It's indicating a potential problem now. Oh, because we're on high impedance. But if I go to low impedance, then it's going to think everything is good because it's actually connecting it to ground. So if this connects to any one of the other sense leads, it's going to be telling us things are all right. Not necessarily good. So important to make sure you wire it up properly. And even though we actually do have live volts on one of these wires, it's telling us it's green. So only one of these wires is being used to detect that the mains is there, I think. Okay, anyway, let's get this back to the way it would normally be used. Now we've got L1 being indicated and a test is indicating that we've got mains present. Okay, the other two phases are going to do exactly the same as what I'm doing with this single phase here, so I'm not going to go in and check those again. I think when things are wired up properly, this is still providing a good test for the mains. There is a scenario though that we've just seen where if the wire fell out and either touched ground, one of the other wires that was still connected but at low voltage, or had a low impedance path to ground, it is going to indicate that everything is okay and one of those wires is still live. That's an issue, because that could be 400 volts or whatever, you know, that could be sitting on there. So, not impressed. I know we're putting a fault scenario in here, but the whole point of this device is to make sure that things work properly, that people have turned off all the power. And if you can wire this up incorrectly, or if a wire just falls out, gets broken, whatever, and it starts telling you everything is green, and we've just seen it is not, that's a safety issue. I can understand it giving you a, oh, I can't talk from brown to brown. But talking from brown to through the other ones to brown with a low impedance path, and when one of those brown wires is still at 120 volts and telling me that it's okay to stick my mitts in there, no, sorry, fail. Okay, welcome back. I've disconnected all the wiring. We've already had a look inside here. What I want to do now, this thing's failed as far as I'm concerned, is I want to have a look inside this unit. Let's just have a quick peek inside, take 5-minute teardown, I guess, and see what's in this, because I'm curious now, especially considering that it failed the test. So let's open her up and have a deke inside if we can. Okay, let's lift the lid. Oh, okay, we're not potted, so that's good. Well, looks like it's conformally coated, which is kind of nice. Lots of surface mode. I have none of this connected to mains, just to reconfirm to you guys. All of the surface mount resistors are, looks like 330K, 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 so that would be basically a megohm, and they're put in series. So these are obviously being chained for maintaining the voltage breakdown parameters of the resistors, so that's nice to see. That's 334s, 334s over here, and there should be another, oh there, another one, 334s. So these are probably the 3 phases here. There's a few other ones around that are 7503s and 474s, so 470Ks, and they're probably voltage dividers or something like that. So we've got the main sense, and then maybe, I don't know. Anyway, let's pull the, I don't know if there's screws behind here or if it's just gonna pull out for us. Okay, so finally got into it. Here's one of them. Let's just zoom in a little and have a look. As you can see, this is pretty much a few resistor dividers. The connection probably going to be for going down to the bottom board, and a bunch of, looks like, protection caps or NTSCs to prevent any inrush and damage happening and stuff like that. So this first board, that's all it's for, is just input protection and voltage dividing. That's it. This second board right here, let's just get this one out the way. This one, it's heavily conformally coated, so it's difficult to see what's on here. I actually can't find anywhere that would necessarily be powering this, because everything comes down on these connectors. If I zoom out just a little bit so you can see it all in shot, there we go. we've got the connectors, the main board. There's no other connections down here. We've got our 2 relay outputs here, which looks like they're going to be just opto-isolated solid-state relays or something like that. Whole bunch of surface mount, looks like little inductors and things down here. They're emblazoned with L. Oops, can't focus that close. Yeah. These are all indicated with an L. You got some switching transistors around them. So these are probably little inductors just to isolate things. I can't see anything that would be directly rectifying any mains voltage coming in here to power this. So, and I'm not about to start trying to trace through all of the PCBs because it looks like it may be multi-layer as well. Yeah, most definitely is multi-layer. It's their own brand of board. So, I don't know what else I can identify. It looks like there's a processor indication on that chip. I'm just going to grab a magnifier and see if we can identify it. So, looks like the processor is an STM32, and these are MCP6664s. Haven't identified what they are, but I'll put a pop-up right here somewhere to tell you what I think those things are. The rest seem to be, it's very difficult to read what's written on them because of all the conformal coding everywhere. And I'm not going to try and scrape it off because I'll probably make this thing not even work at all. But anyway, I think that pretty much completes what I want to do. A little disappointing that I found a scenario where this thing will actually break or give you a false reading. That in itself would basically disbar this from anything that I would want, that would be critical, because you could kill somebody. And I'd rather go back to the meter mode, which, yes, takes you a lot longer to do, but, you're making sure that the voltages are gone. We found that just one wire pulled out and touching either the case or something else, which often will happen if wires fall out, will give you a scenario where even though one of the pins has got mains on it, it'll tell you that there's nothing in the cabinet, no live, and there was a live. If both of them fell out and it told you that it couldn't determine it, or that they were grounded, well, okay, you could see that maybe, but having a situation where there is mains in there, you're putting your life in this thing's hands, and it can lie to you in certain scenarios. So, not happy. I mean, I like the idea, and I like the potential saving of time and everything else, but I don't know. You tell me. What do you think? Put in comments. So, anyway, that's it. Review over, and thanks for watching. Bye.